The world of API authentication and authorization can be a confusing place. You have lots of similar sounding terms like access tokens, refresh tokens, API tokens, OAuth, OpenID Connect. Heck, even authentication and authorization are easily confused. But as developers, we simply want to call these APIs securely without having to know all the details of every single RFC about OAuth. Hi everyone, my name is Sydney, and I'm an identity architect. And part of our job in identity at Atlassian is to make API auth a lot simpler for everyone. So today, we'll cover two things. Firstly, we'll give a bit of background around API auth in general and focus around OAuth, right, which is an industry standard and it's where a lot of our development is focused on. Then we'll switch gears and talk about best practices for when you're developing your apps to call our APIs. So let's get started. So API auth is around authentication and authorization, but what are these two concepts? Well, authentication is all around identifying things. So identifying who the user is and also the system or the client that they're using. And once you're identified, then we go to authorization, which is where we check, does the user actually have access or permissions to do something? And similarly, is the client that they're using also allowed access to do these things? So how does this work with APIs? Well, here we've got the three pieces of an API transaction. You've got the user, the client that they're using, and the resource server that holds the data they want to access. So the first thing is the user has to somehow establish a client resource trust with the resource server. All right, so that establishes the client authorization piece. But to do that, the user themselves have to authenticate and be authorized to do so. But once all this is set up, the client is given some kind of token, either directly or indirectly by the user. And that token can then be used to access resources with the resource server. So that's where that token's only generated once client authorization has happened. And token generation also is where client authentication can happen as well. So let's make this a little more concrete and talk through how it applies to various API auth methods. So firstly, let's start with basic auth. All right. So here the token itself is just the username and password from the user. All right, and so there's no actual explicit client resource trust because there's no way for the resource server to distinguish between different clients or even between the client and the user itself. The next level of sophistication is session-based auth, so like the legacy Jira Sessions API. All right, so here the user authenticates and is authorized against the resource server directly and passes the session token to the client. All right. But again, there's no explicit client resource trust here because there's no way for the resource server to distinguish between different clients. So the next level up is what we call user API tokens. So if you go to, say, your user profile screen in applications, you'll be able to create these look like random strings that you can copy and paste into scripts that you're using. Now, while there's no explicit client resource trust here, the nice thing about API tokens is that as a user, you can create many API tokens. And so you can kind of at least distinguish between different clients or at least different API tokens when they're used. And also the tokens are limited. Typically you're restricted to, say a specific Bitbucket repository or so forth. So it provides a little bit extra protection. And that's why we're highly recommending users use API tokens rather than pure basic auth. All right. Then we get to OAuth, which is like the full whiz-bang solution. All right. It has explicit support for client resource trust establishment, and also has more sophisticated tokens. So there's access and refresh tokens, which we'll get to in a minute. All right. So let's jump into some of the details you need about OAuth. Right. OAuth is a really big standard, but hopefully we'll sort of narrow it down to the minimum you need to know. So first, let's start with some of the key concepts. All right. We've kind of already talked about the clients and the ability to identify individual clients. All right. So in OAuth, each client is given a unique identifier as well as a secret, which is kind of like its password. All right. Clients are also distinguished between whether they're first-party clients and third-party clients, and also if they're native versus browser versus like server-side. All right. And these all feed into the various OAuth flows that provide very secure mechanisms for different types of clients. Next, there's the authorization server. So what OAuth does is split out all the AuthZ components and the token generation components and authorization management out of the resource server into a separate reusable component, which is really nifty for reuse between various resource servers. All right. Next are scopes. So scopes represent sort of permission strings that define what operations a client can do. So maybe clients can manage conversations or create issues or so forth. Now there's grants which tie all these things together. All right. So think of grants as like a permission rule that link the user, the client that they're using, the scopes that are authorized, and the resource to which the actions or scopes are allowed on. All right. Now, so OAuth is really all about generating or storing these grants and generate tokens based on these grants. And hence they define various what are called grant flows. So there are a lot of these flows, but the four main ones you'll hear about are firstly, resource owner password, which is kind of like basic auth or for the login screen essentially. The second one you hear about is what's called client credentials, and that's where clients act on its own behalf. So think about chatbots, for example. Next, we have the authorization code flow, which is what Diogo mentioned in his keynote. And that's where a backend client can sort of act on behalf of a user. And finally, there's implicit flow, which is used when you only have a front-end client where you can't store any secrets, but it's very similar to the auth code flow sort of mechanism. Now, we're only going to focus on the client credentials and the auth code flow today because if you understand these two, you'll understand most of what you need for auth. Now, I'll go through a couple of slides with lots of arrows describing how users are redirected and so forth. But I think keep things simple. All right. Think of only these four components. So you've got user, the client, the authorization server, and the resource server. And all boils down to is, firstly, a user needs to authorize a client to do something, right, to establish those grants. Once that happens, a client can then get an access token using its secrets. And it can then use the access token to access the resource server. All right? And the resource server that validates that access token in conjunction with the authorization server. This itself is pretty much what OAuth defines. All right? So if you remember one thing today, this is the slide to remember. All right, so let's talk through client credentials flow as a first step. So here, like I said, there's no real user interaction because the client is working on its own behalf. So all the user does initially is to, install or set up that initial grant via some out-of-band mechanism, like a chatbot installation, for example. But once that happens, the client backend uses its ID and secrets to get an access token from the authorization server. It then uses that token to access the resource server. All right, so that's simple. Let's step it up to the auth code flow. All right, so here, the user starts by opening the application, right? So it goes to your client application in the browser, say. The client then redirects the user to the authorization server, requesting specific scopes in a particular resource server it wants access to. So the authorization server then presents a consent screen to the user, which the user can then consent to, in which case the authorization grant is stored in the authorization server. So the AuthZ server then redirects the user back to the client with a one-time authorization code that the client backend can use to exchange for its access and also a refresh token, which I'll get to in a minute. So like in the client credential case, the client can use the access token to communicate with the resource server and get access to data. Now these access tokens are limited in duration, right? And maybe an hour, maybe a day or so. And you don't want to have to keep on going back to the user to get new access tokens, right? That's going to be really poor UX. So the refresh token allows the backend client to go and talk to the authorization server to get access tokens without having to involve the user. As so. So you can kind of see this diagram is really complicated, but really it all boils down back to this simple place, right? Where you've got user authorizing client getting access tokens and using those access tokens to access the resource servers. All right, so that's OAuth. Now let's jump into some sort of best practices, like tips and tricks for API consumers. Firstly, let's talk about security. All right, so part of API access, we deal a lot with tokens and credentials, right? Like client IDs and secrets, right? These are essentially like passwords, right? And so you have to secure them. Things to keep in mind are like encrypt them at rest, for example, right? So luckily, if you're in the cloud, you can use tools like AWS Key Management Service or Secrets Manager to help you do this really easily, all right? And for example, don't put them into your Git repository, little things like that. The other thing to bear in mind is you can't really trust client devices or browsers, right? So while you may be able to store them in sandbox systems in local storage, for example, you can't really trust that attackers can't get to those. It's actually quite easy to get to those compared to your backend services. The second thing to bear in mind is you should verify who you're talking to as well, all right? So OAuth luckily has this state parameter as part of its flow to prevent sort of cross-site request forgery attacks. So make sure you set a random variable as that state parameter and actually verify it when you get that auth code back. All right, that's really important, but really easy to forget. And also, we're all using HTTPS, right? But don't forget to validate your certificates as well. It's very easy again to wrap all HTTP client calls with some exception handling that just generically handles every exception, right? So just be a little bit careful about that. And finally, just generally don't be greedy in a couple of cases of this. So firstly, scopes represent permission requests, right? So try to ask for the minimum set of scopes that you really need, both because you really upset users if you ask for too much. Like, for example, why do you need to edit issues when I'm just viewing things on my homepage, for example? And secondly, if you happen to lose your credentials or tokens, at least you're not you're limiting the blast radius of damage. Now, the second thing to note is the access tokens you'll get back. These days, they're typically JWTs, right? They do have some useful information in them, but these are kind of like hidden sort of details, right? You shouldn't have to worry about. So don't try to inspect these access tokens, or we'll change the format, for example, and your code will break. So the next thing I want to bring up is that while diamonds are forever, tokens aren't. All right. So access and refresh tokens have lifetimes. All right. And also bear in mind that at some point a user may choose to uninstall your application or revoke their grants. All right. So you may well get unauthorized errors during normal flow, when you're accessing resources or trying to obtain new access tokens. So the general solution is just to reauthorize or kick the user through a reauthorization flow. All right, and to be honest, just in general, be spec compliant. And the easiest way to do that is just to use standard libraries. All right, don't try to roll your own OAuth support yourself. All right. So moving on to some Atlassian specific things. So one of the things we're moving towards is api.atlassian.com as the single entry point for all Atlassian APIs. All right, and that nice thing is that we're now able to move beyond tenanted hosts. All right. So it allows easier cross-product applications, like you can access Bitbucket APIs at some point at the same time as Jira APIs through the same endpoint, right? It also allows for better user experience, right? So rather than have to reference a particular customer's Jira instance as foo.atlassian.net, you can say it's Foo Company's Jira instance. From a technical perspective, this also means you have to store a lot less tokens, right? So you don't need per tenant tokens anymore. You just need one token for a given user for your app. So before finishing up, let me go for a couple of frequently asked questions I get around OAuth or API auth in general. Firstly, with OAuth, being like the bee's knees for everything, like it covers all cases. So why would we use OAuth? Why would we even use API tokens at all? And it comes down to different use cases here. So OAuth is really targeted for developers and apps, right? It gives you an application installation experience, all right? And as a result, you don't have to get users to copy and paste tokens from one place to another place, all right? So that's really nice. On the other hand, API tokens are for admins and users, all right? And if they want to run simple scripts or hit APIs in a one-off manner, it's really easy for them just to get an API token and use that, rather than have to go and create an OAuth client, bring in OAuth, libraries and so forth, just to do a simple task. So one other thing I get asked a lot about is, I hear this thing called OpenID Connect in the same context as OAuth. So what's the difference? So OpenID Connect is all around user authentication, right? It allows you to delegate authentication of a user to another system, say, log in with Google or with Facebook and so forth. Right? It actually has nothing to do with using an API on behalf of that user, right? And why it's so confusing is that, OpenID Connect actually is built on top of OAuth, right? And the way to think about it is OAuth itself is really just a set of design patterns in a way, right? There's nothing really specific about API authentication authorization about it. And so as a result, OpenID Connect has tokens, right? It has access tokens and so forth. But just remember, these access tokens and tokens you get are really about users and dealing with user APIs from the identity provider, not about accessing APIs on behalf of the user. All right, to sum up, there's probably three things to take away from today's talk. Firstly, around the OAuth flows, just remember that really simple diagram, right? So your user authorizes a client, clients get access tokens from the authorization server and uses those access tokens to talk to the resource server, and that's it. All right. If you want to dig a little bit deeper, definitely review the auth code and client credentials flows, and once you get those, the rest of OAuth kind of just falls into place quite easily. Secondly, don't forget to protect yourself. Like, it's really important to secure your secrets, like encrypt them at rest. Also, don't forget to use the state parameter. All right, it's a very simple thing to forget, but make sure you use that properly. And in general, just be spec compliant. Like, we'll be adding new features and new security features over time, but as long as you're spec compliant, you won't even notice. All right, and you'll get security benefits for free. And as part of that, remember, if you ever see failure cases like unauthorization errors, just kick off another authorization flow for the user, right? And to help you do that, use standard libraries, right? There's one out there for every single tech stack. So I've listed a few useful references here. I particularly like looking at the RFC for the OAuth 2 threat model. There's a lot of interesting attacks there and I like to bear in mind. And on that note, thank you very much for listening.